All right, 6.3, day 2. And last time we did adding and subtracting, and now we're gonna do multiplying. And then also we're gonna kind of do divide, but divide, you really don't divide, you just rationalize the denominator using conjugates. Which I'm not sure if we talked about that or not, but it's a pretty fun math word called conjugates. So here's what a multiply one will look like, right? And that's actually a preview of what conjugates are. They look like that, where they have the same real parts and then the same radical parts. And all that's different is there's one's a plus and one's a minus. And when that happens, it's called conjugates. We'll get a formal definition later. All right, so multiply is just FOIL, right? You've done this a bunch, except now it just has radical symbols in it. All right, so jot this one down in your notes. And if you want to give it a shot, you might be able to do it right away already. All right, so I'm going to write out the parts of FOIL. So the first two are 6, 3 times 2. The outer 2 is 3 times 4 radical 5. The inside 2 is 2 radical 5 times 2. And the back 2 is 2 radical 5 times 4 radical 5 is 8 radical 25. Actually, probably I should write it out first. Let's go back a step here. So it'd be 2 radical 5 times 4 radical 5. Okay, and now let's clean all these up. So 3 times 4 gives us 12 radical 5. These are all plus, I guess. I should say that. There's no negatives in this question. This would become 4 radical 5. Multiply the two non-radicals. And then in the back, we multiply the 4 and the 2. And then the radical 5 and the radical 5 to get radical 25. Now I just got to keep cleaning it up. So this back part is actually going to become 8 times 5. So that's going to become a 40. And in the middle here, we can add these together. Those are like terms to give us 16 radical 5. Okay, and now the 40 and the 6 becomes 46. So we have 46 plus 16 radical 5. All right, and that's it. So you just got to FOIL, and then when you're FOILing, you can multiply two regular numbers and two radicals. You can't like mix and match, right? I can't do like 4 times radical 5. There's no way to multiply those. One's a radical, one's a regular number. All right, slightly different twist here. So see if you can multiply in this case. All right, first trick is to realize this is actually a FOIL question just in disguise. So I'm taking 2 minus radical 5 times another 2 minus radical 5. That's what that little square means. Now it's just FOIL. So 2 times 2. 2 times negative radical 5. Negative radical 5 times 2. And then negative radical 5 times negative radical 5 would become a plus radical 25. All right, so combine our like terms. Negative 2 radical 5 and negative 2 radical 5 makes negative 4 radical 5. And the square root of 25 is 5. So now we do 4 plus 5 gives us 9 minus 4 radical 5. All right, and that's what we get. We multiply those two binomials, and we actually got a binomial as our answer. All right, next up is a definition of conjugate. All right, so maybe if you just want to I thought a good way to do this would be just to list some conjugates. I think examples are maybe like the best way to explain it. So conjugate gets, and basically you just take and do the same 6 and radical 7 part, but just flip the symbol between them. So the conjugate, they have pairs. So these are called a conjugate pair, where they're the same except the symbol between them. So I'm going to give you another one. I'd say, what is the conjugate of that? Okay, and hopefully you can figure out it's 2 plus radical 3. Let's do maybe one more. Let's do 7 minus radical 6. Okay, and the conjugate of that would be the 7, and then it'd be a plus radical 6 there. right? So if you want the general form, you could do like a plus radical b, and its conjugate would be a minus radical b. Okay, and the reason why we bother learning these conjugates is something magical, right? There's a magical property. They're magical. So when you multiply them, you'll see the magic happen. So here's a pair of conjugates, right? They have the general form here, except I did it a little bit different without the root there, but it's the same idea. The two parts are the same with just the symbol that's different between them. So see if you can multiply these and see if you can see what's magical about conjugates. Magic. All right, here we go. So multiply these together. That's 25. 5 times positive radical 7. Negative radical 7 times 5. And then radical 7 times radical 7 is radical 49. And I think it's going to be a minus there because we have negative times positive. Okay, so here's the magical part. With conjugates, these two middle terms, because one is plus, one's a minus, they cancel out. So plus 5 radical 7 and minus 5 radical 7 cancel us out. So we just have 25, and then radical 49 is just 7. So we have 25 minus 7, which is 18. Right? And so that's what's kind of magical, is it cleans up really pretty. Right? So we start with this kind of crazy expression, but conjugates will clean up nice and pretty to give us the 18. And as you get better at this, you can actually kind of skip the two middle terms, right? Because you know they're going to cancel out anyway. So you can just do on this one, I could just do the 5 times 5 and the negative radical 7 times positive radical 7. But if you're first learning, you can multiply all the parts out. All right, one more, right? And you can either skip the middle steps or write it all out. I'll write it all out just for practice, but pause the video and give this a shot. All right, so 3 times 3 is 9. And again, all I really need to do is the other back two, the last two, but I'll write out the middle ones just in case, just to practice. So that'd be a 3 times negative radical 8. Positive radical 8 times positive 3. Again, those two are going to cancel out in the middle. And then radical 8 times negative radical 8 will be negative radical 64. Middle two will cancel out because they're conjugates, right? One's a plus, one's a minus, and everything else is the same. So I end up with 9 minus square root of 64, which is 8. And then subtracting 1. We get that's a pretty answer. Okay, so that's kind of the power of conjugates. And we're actually going to use this when we do our last part, which is really to sort of divide. Okay, so remember before we did rationalize the denominator? And we did it with just a single part, right? We don't have a binomial yet, right? Today we're gonna do it with binomials, but just as a review, see if you can remember what you got to multiply the top and bottom by here to cancel out the radical. All right, so hopefully you can remember, because it's a cube root, I will need to do 2 more cube roots of 3. All right, and I'm going to do that to the top and bottom. The point being, again, this denominator will now become a cube root of 3 times 3 times 3, which is 3 cubed. And then that will just become 3. So the whole point was doing 2 more to wipe out the radical, so you just have 3. And then up top, we just have to do radical third root of 2 times third root of 3 times third root of 3. That's going to be a third root of 18. And that doesn't simplify at all, so we just leave it like that, and we are done. Right? And we got rid of the radical symbol in the denominator. It is allowed in the numerator, but we wiped it out in the denominator. Yeah, so today we're going to do that, but just with binomials. So let's take a look at this binomial expression here. And we want to get rid of the radical in the denominator. All right, so this will be a good sort of test to see if this made any sense at all, or if I'm just a terrible math teacher. What would you multiply the top and bottom by? Play some Jeopardy music. Do, 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 do. Okay, so the deal is you want to do the conjugate. And the reason is it cleans up. So if you go back and look at our conjugate questions, go back, my computer will work here, right? When you multiply by the conjugate, it comes out nice and pretty. Okay, so we're going to do that same thing here, where we're just going to take the conjugate of our denominator, which would just be 5 plus radical 3, and multiply that with the top and bottom. Okay, and so in the denominator, I'm going to maybe do the short version of this because the middle parts are going to cancel out again when you do conjugate. So do 5 times 5 is 25. And again, it would be minus 5 radical 3 and plus 5 radical 3, so they'd cancel out. So I'm just going to do multiply those together, and that will be negative root 9, root 3 times root 3. And again, the middle two cancel out, so I'm not even writing them. So I have 25 minus 3, 22. So our conjugate comes to save us there, and we just get a 22 in the denominator. All right, numerator then, I'm just going to I'm going to distribute. So 3 radical 2 times 5 would be 15 radical 2s. And then 3 radical 2 times radical 3 would become, let's see, 3 radical 6. All right, and that's it, right? We wiped out the radical in the numerator, and boom, we're done. All right, just one more of those for you to practice, all right? So here it is. You're on your own. All right, so hopefully you've done this question. Now we'll go through the answer. So we're going to multiply to get rid of this. We want to rationalize the denominator. So to get rid of this radicals in the denominator, we multiply by the conjugate. Okay, so we're going to multiply by radical 3 plus radical 5, top and bottom. All right, and maybe I'll do all the steps here, just if you want to see the full FOIL steps here, just for fun. In the bottom, radical 3 times radical 3 is radical 9. Radical 3 times positive radical 5 is plus radical 15. That's the outer two. The inside two are these two, so that's going to make a minus radical 15. They're going to cancel out here in a second. And then the last two would be negative radical 5 times positive radical 5. So it'd be negative radical 25. So the middles cancel out. We end up with 3 minus 5, negative 2. Okay, so our denominator is going to be negative 2. And our numerator would distribute that in. So that would be 2 radical 7 times radical 3. So 2 radical 21. I guess I could just write it right there. And then 2 radical 7 times radical 5 would be, let's see, 2 radical 35. Okay, and if you want to leave it there, that's just fine. If you really want to have some fun with it, this negative 2 would divide out the 2's on top. So we'd have negative radical 21 plus negative radical 35. Right, divide the negative 2 into both of those. So that would be the cleanest answer. And I don't think it cleaned up anymore from there. So we could just leave it that way. Even if you got it here, I'd probably call it good on a test or something. All right, so this lesson we multiplied binomials, radical expressions, and then we really didn't divide. We just rationalized the denominator, cleaned it up by multiplying by conjugate. Thank you for watching.